Hello students, welcome back to CPU scheduling algorithm examples. So last class we have understood the different CPU scheduling algorithms like first come first serve, shortest job first, round robin, priority scheduling. So now let's see examples on each of these. So first come first serve. What is first come first serve? First come first serve means a process as they enter into the ready queue, they are allocated the CPU for execution. So until unless the first process doesn't finish execution, the next processor will not be given the CPU for execution. So let's see an example on this. Problem 1. Given the following processes and CPU burst time, assuming all processes have arrived at time 0, compute average waiting time and average turnaround time. Such kind of problems will be asked in your exam and the questions will be similar. So the table that is given is this. So here process P1, P2, P3 is given and CPU burst is 24, 3 and 3. Now remember that there is no arrival time given. It means that you need to assume that the arrival time is 0. Problems can be given with arrival time as well. So we will see examples of non-arrival time, that is 0 arrival times, as well as different arrival time process execution, also how to calculate their turnaround times and average waiting times. So let's first understand the basics of how to compute turnaround time and waiting times. So in this example, first we have to do is we have to draw a Gantt chart. To draw a Gantt chart, you need to draw a table like this, wherein you are specifying which process starts at time 0. Next, how much time it takes. So P1 here is told that it is having a CPU burst of 24. So that means from 0 to 24, it will take time for execution. So CPU is allocated to P1 for 24 milliseconds. Next, P2 is the process. So P2 requires 3 units of time. So CPU is allocated to P2 for 3 minutes. So from 24 it starts and it finishes at 27 milliseconds. The next process P3 starts at 27 and it also requires 3 milliseconds. So it will finish at 30 milliseconds. Next, we need to calculate their waiting times. To calculate their individual waiting times, we need to calculate what is the start time. We have to minus in that the arrival time and we get the time that is required for its waiting. So P1 started its processing at time 0. It arrived at 0. So 0 minus 0 is 0 milliseconds. P1 did not wait for anybody else. As soon as it entered the system, it was given the CPU and it executed. Next process is P2. P2 started its execution at 24. So it had to wait for P1 to finish and leave the CPU. So it waited for 24 milliseconds. It arrived at time 0. So total minutes it waited was 24 milliseconds. Next is P3. P3 started its time processing at 27 milliseconds. It arrived at time 0. Hence it had to wait for 24 milliseconds. So the formula for computing the average waiting time is to compute the sum of all waiting times, that means 0 plus 24 plus 27, and divided by the total number of processes in the system. So here the total is 24 plus 27 divided by 3, which is 17 milliseconds. So an average waiting time for all these three processes is 17 milliseconds. Next, we need to calculate the turnaround time. So again, for the turnaround time, the system is given to us. And in this, we use a Gantt chart. So as I told you already that P1 started at time 0, P2 started at 24, P3 started at 27. So P1 finished at 24, P2 finished at 27, and P3 finished at 30. So in calculation of turnaround time, we see what time the processes finished its execution. So we need to keep a track of what time they finished. In waiting time, we see when they started their execution, whereas in calculation of turnaround time, we see when they finished their execution. So next, we calculate each of the processes turnaround time. So each of the processes turnaround time is for process P1 finished at 24 milliseconds since it arrived at time 0. So the total turnaround time for it was 24 milliseconds. Next, it process finished at 27, P2 finished at 27 and its turnaround time was, that's the total duration that it was there in the system was 27 milliseconds. Next one is P3 which finished at 30th and so its turnaround time is 30 milliseconds. So how to calculate the average turnaround time? The average turnaround time is equal to sum of all processes turnaround time divided by total number of processes. So the calculation is 24 plus 27 plus 30 divided by 3 because there are three processes in the system. So total is 27 milliseconds. So each of these processes average execution time will be 27 milliseconds. So that is the turnaround time. Let's see a similar example. Now, in this same example, we have changed the process order. We have taken P2, P3 first and then P1. Let's see what will be the difference in average waiting time and average turnaround time. What do you think? Does the average waiting time and turnaround time reduce or will it increase? Here, in this example, if you see, now the average waiting time and the average turnaround time decreases as the process are here with less CPU burst are first and higher CPU burst is last. So in the previous slide we saw that P1 was first and hence its CPU burst, as its CPU burst was high, it was keeping the CPU engaged for a longer time, and process P2 and P3 which were having a lesser CPU burst had to wait for a long time. Hence this effect is called as a Conway effect. The Conway effect is an effect where a short process is kept behind long processes. So this is what will cause the average waiting time for all processes to increase. So if you have a proper mix between processes of IO burst and CPU burst, you can have a good lesser or minimized average waiting time. Similarly, you can have the turnaround time also reduced. Next problem we will see wherein we have arrival times. So how is the same program going to be different now? So if you see their Gantt chart is same, they are finishing also at the same time, we are starting also at the same time, but the difference is in their waiting time. The individual waiting time has changed. In the previous example, we saw that process P1 has having a waiting time of 0, but process P2 was having a waiting time of 24, but here it is 20 because it arrived at 4 milliseconds. P3 started its processing at 27, but it arrived at 6 milliseconds. So we have to remove that amount of time that it was not there in the system. So it is total 21 milliseconds it was waiting. So again calculate the average waiting time, sum of all the waiting times divided by number of processes, which is equal to 13.76 milliseconds. Similarly, let's calculate the turnaround time for the system. Again calculate what time the process finished minus what time it arrived. You will get the turnaround time for each of the processes. So 27 was the time when P2 finished its execution. It arrived at 4 milliseconds. So the total turnaround time was 23. Then for the third process, it finished at 30. It arrived at 6. So total turnaround time for that was 24. So the calculation is now 23.67 milliseconds. Next, let's see another problem. Consider the following processes which have arrived at the ready queue with the burst and arrival time given in milliseconds as shown below. Draw the Gantt chart and calculate the average waiting time. So this is the processes. There are 4 processes. These are the CPU burst and there is arrival time. So we have drawn the Gantt chart. So first process P1 requires 8 milliseconds. It has a CPU burst of 8 milliseconds. So it will finish at 8 milliseconds. After it finishes, P2 takes up the CPU and it finishes at 12 milliseconds because 8 plus 4. P2 started at 8 and it requires a CPU burst of, it is having a CPU burst of 4. So 8 plus 4 is 12. Next P3 requires a CPU burst of 9. So it started at 12. So it will finish at 21 milliseconds. And next process that will be executed by CPU is P4 since it started at 21 and it requires a CPU burst of 5. So it will finish at 26. Let's calculate the waiting time for each of them and then calculate the average waiting time as a sum divided by the total number of processes. It is coming up to 8.75. Similarly, let's calculate the turnaround time now. So this is again the CPU burst and when the process is complete and we calculate what is the turnaround time for each processes, then calculate the average turnaround time. So this is calculated to 15.25 milliseconds. Next we will see shortest job first, non-preemptive example. So in this case, the process that is given the CPU will finish its execution and then only the next process, shortest job, will be given the CPU. So let's consider this example. Again, we are having the same example here. So in this case, the first process P1 has entered the system with a burst of 24. Next, P2 has entered the system with a CPU burst of 3 and last P3 has entered with a CPU burst of 3. So all are arrived at 0. So you can consider any process first and draw. Since it is all arrived at time 0, the shortest job in this system is P2 with a CPU burst of 3 and even P3 with a CPU burst of 3, but we will consider P2 first. So P2 is allocated to the CPU, it gets executed for 3 milliseconds. Next shortest job is P3, which will get executed, which will start its execution at 3 milliseconds and it will end at 6 milliseconds. Then next is P1, which will start at 6 and will finish at 30. So the waiting time for each of those processes are 0, 3 and 6. So now if you compute the average waiting time, it's only 3 milliseconds. Next turnaround time. Again for the turnaround, sorry, next example here is with 4 processes and their arrival times. So here we are calculating. Again we have drawn the Gantt chart same as the previous slide, and only thing is we have considered the first process that we have considered is P1. Now P1 is considered first because at time 0 that was the only process. These have arrived at 1, 2 and 3 if you see. So at time 0 P1 was the only process that was there in the system. So P1 is allocated the CPU. P1 starts at 0 because it's a non-preemptive version. It finishes then only leaves the CPU. So all the 8 milliseconds P1 is executed by your CPU. At the end of 8 milliseconds, if you see now this last process that has arrived at is 3 milliseconds. So all these 3 processes are there in the system when P1 finished its execution. So we have to check whose CPU burst is the smallest among these 3 and allocate that process the CPU. So in this case, P2 is having the smallest because it's having only 4 milliseconds. So P2 is allocated the CPU for execution. Since its CPU burst is 4, it will finish at 12 milliseconds. Next smallest, then the remaining 2 processes which are not still executed are P3 and P4. In that, who is the smallest CPU burst? 5. 5 is the smallest CPU burst. So P4 will get executed next, and since its CPU burst is 5, it executes and finishes at 12 milliseconds. And last one is the CPU burst with 9, so it will get executed last. So P3 finishes at 26 milliseconds. So this is the processing time minus arrival time. So process P1 came at time 0 and started at time 0. So the total waiting that it had to do is 0. Next process P2. P2 started at 8 milliseconds, but it had arrived at 1 milliseconds. So total time it had to wait is 7 milliseconds. Next process is P3. P3 started at, if you see here, P3 started at 17 milliseconds and it came at 2 milliseconds. So total minutes it waited was, total milliseconds it waited was 15. Next process P4 started at 12 and it had arrived at 3 milliseconds. So it finished at 9 milliseconds. So next, calculate the average time as sum of all the average time, all the waiting time divided by 4, because there are 4 processes, you get 7.75. Let's calculate the turnaround time. Same process, same way it's executed. So you need to calculate the finish time. So finish time, P1 finished at 8 and it arrived at 0. So the turnaround time for P1 is 8. Next process finished at P2 finished at 12. So 12 and it arrived at 1. So 11 milliseconds is its turnaround time. Next is P3. P3 finished at 26 and it arrived at 2 from this table, if you see. So it is 24 milliseconds of turnaround time for P3. P4 finished at 17. So 17 is when it finished. It arrived at 3. P4 arrived at 3. So the turnaround time for P4 is 14 milliseconds. So calculate the average turnaround time. You add all of them and divide it by 4. You will get the average turnaround time. Next is solve the following SJF. Use solve the following examples and submit it in Google Classroom. So we will see the shortest job first, primitive version, in the next lecture. Thank you.